Good morning, and in this video we are going to discuss about one of the important vocabulary and important terminology in the NMR spectroscopy. It is chemical shift. So chemical shift is the value to measure the NMR graph. Here these are the values you could find in the NMR graph, and generally it is denoted by delta value, right? So generally this NMR spectroscopy is a tool to identify the structure, especially in proton NMR, which is used to identify the structure of or the connectivity of organic molecules, right? So here this is the chemical shift value. So how we can define chemical shift is, so chemical shift is the difference in Larmor Fresnel frequency of the sample and Larmor Fresnel frequency of the reference compound. Here, when you are discussing or when you are using this Larmor Fresnel frequency, means this Larmor Fresnel frequency identify the or indicate the Larmor Fresnel frequency of protons exclusively, right? So here I have mentioned a reference. So for any spectroscopy there is a reference. Okay, so with respect to this reference we will calculate how Larmor frequency of this proton and this proton are different from this reference protons. Generally in 99% of NMR proton NMR spectroscopy we use TMS, tetramethylsilane. TMS, tetramethylsilane, right? So for example, let us discuss if we subject all these things. Okay, so we are going to take all this reference and the sample we are going to trace under proton NMR. Okay, in NMR reference vessel, right? So at 1.41 Tesla of external magnetic field, these reference protons are set to presses at 60,000 megahertz, right? So arbitrarily, so let us suppose this proton B and proton A. Here you can identify the connectivity of or the environment around this proton is different from this proton, right? Here this is connected to carbon, which is connected to another carbon and two X groups, and here this proton B is connected to carbon and this carbon directly connected to another carbon and two Y groups, right? So you can easily identify these two protons are falling in different environments, right? Means they are in a different environment, so they will process with different Larmor frequency. We have already discussed in the last video factors influencing the new Larmor frequency values, right? Precisional frequency value. Suppose this one is not megahertz value 60 60 lakhs. Six crores hertz, that means 60 megahertz, right? And this proton B is precising with a 6 crore 100 hertz. So, and this proton is in precision with 6 crore 200 hertz, right? So here chemical shift in hertz is equal to chemical shift of the Larmor frequency of the sample minus Larmor precisional frequency of the reference proton, right? So let us try to calculate from above values that here Larmor frequency of this HA is 6 crore 200 hertz minus reference protons for TMS, it is 60 megahertz, that is equal to 6 crore, right? So the difference is 200 hertz, and for HB proton, if you calculate, you are going to get 100 hertz, right? Okay. Right, and here I am going to do the same experiment by exposing the reference, it is case 2. So here instead of using 1.41 Tesla, I am using 2.82 Tesla, right? So if I double the external applied magnetic field, right? So now the precisional frequency of all the protons will become double. We have already discussed that precisional frequency is proportional to applied magnetic force, applied strength of the applied magnetic force, right? If I double this precessional frequency, so here reference protons will precise with 12 crore hertz, that is 12 megahertz. These are the reference. And HA, if you double the precessional frequency of HA, so it will become 12 crore 400 hertz, and HB will become 12 crore 200 hertz. And if you calculate the chemical shift now, is for HA it is 400 hertz, and for HB it is 200 hertz, right? So here for the same molecule, same sample with same reference, okay, at 1.41 Tesla, the chemical shift or the difference in the Larmor frequency of sample and Larmor frequency of reference protons is like this. In case 1, 200 and 100, right? And if you double the strength of the external magnetic field, so the chemical shift values are doubling or changing, right? So if you go on changing this H naught value, okay, external magnetic field value, right? So these chemical shift values are also going to alter or change, right? But in a graph it should be a definite number. So to do away with confusion, we have to propose a ratio which will not alter with the strength of the magnetic field or the energy of radio frequency source. Okay, so to do that we have to give some other definition to chemical shift values. So these chemical shift values are not supposed to change with the strength of the magnetic field or the energy of the radio frequency source, right? So to do that, so we are going to take the ratio of the difference in the Larmor frequency values of sample and reference, sample and reference, and with respect to or upon frequency of radio energy source, frequency of radio energy source or frequency of the instrument or the energy of the instrument, right? So here again you can define like this: new sample minus new reference upon new instrument means what is the energy of the radio source we are using, right? And here, so to do away with the large numbers. Okay, so here you can see that you are using very large numbers. So in common discussion it is very difficult to use these terms 6 crores, 120 crores, or 12 crores, right? So instead of using that, so we are using, so this is in the instrument will be having megahertz, right? So we are going to, right, multiply. Okay, so to do with, we are just using 10 to the power of 6 ppm, parts per million. 10 to the power of 6 parts per million, right? And so let us find out the above cases. Okay, so in case 1 and case 2 for both HA proton and HB proton. So in case 1, HA proton has, so this lambda sample, lambda reference, chemical shift of 200 hertz, and there we are using 60 megahertz, right? So here we are not going to use mega values, because to do away that we are using 10 to the power of 6 ppm, right? And this is for HA proton, and lambda HB will be like this. 100 is the difference upon 60 hertz, right, into 10 to the power of 6 ppm, right? So now and then we generally do not use this term, but you should remember this term, right? And in case 2, delta HA, the difference is 400 hertz, and the source is at 120 megahertz. So 10 to the power of 6 ppm. And for HB proton, the difference is 200 hertz, and the source is having 120 megahertz energy. So, right, and you need not to bother about these hertz, megahertz, because we are multiplying this with the 10 to the power of 6 ppm, right? So 10 to the power of 6 parts per million hertz, right? So you need not to bother about these values. So to do away this one, we are using this one, right? So let us see in case 1. So this chemical shift value is 200 upon 60, and for HB 100 upon 60, right? In case 2 also, lambda delta HA is equal to 400 upon 120, and for HB it is 200 upon 120. So both are one and same, right? Both are same, right? So this is how we can achieve a generalized formula for chemical shift, right? So 200 upon 60, 100 upon 60, 400 upon 120, 200 and 120, both are one and same, right? So if you simplify, both will get same values, right? So here you are going to get around 3.3 3 value, and here you are going to get around 1.6 delta value, right? Here also you are going to get the same values, 3.3 value and 1.6 value. So if you propose this formula, you can generalize the chemical shift with any type of radio source or any type of external magnetic field, right? So chemical shift, it is the difference between Larmor frequency values of sample and reference, or in another words, as I said, in the graph of NMR spectroscopy, you find this delta values along x, right? So here reference will be there and sample, so sample should be like this. These are all the graphs of samples, right? And here, so the position of the sample protons in NMR graph with respect to reference is called as chemical shift. Okay, the position of the sample protons or sample nucleus in NMR graph with respect to reference is called as chemical shift. All right, so let's stop here.